Alrighty, so in this lesson, we're going to tackle some integrals involving where the result, the answer to the integral, is one of these inverse trig functions. So arcsine, arctangent, or arcsecant. So remember, these are like opposite of the sine function or the inverse of the tangent function. And these are our derivatives rules for these particular functions. We don't run into these a whole lot, so you may not have these memorized. For our integrals rules, I actually don't want you to use these. These are from the reference sheet that I gave you. Because these, before I cross them out, these only allow us to deal with these like factors of 1 in the function, but don't allow us, so say like I took a derivative of, I don't know, arctangent of x squared over 5. They don't necessarily allow us to capture that very well, because what will happen is I will do chain rule, and then this derivative, by the time I simplify it, will start to look a lot different. Okay? It turns out that these still follow a similar pattern, but I'm going to give you the rules in a slightly more complicated way so that they're easier to apply. So take a second to copy these down before moving on. So notice these involve slightly more complicated, or these allow us to tackle slightly more complicated situations like this, where I don't necessarily just have a 1 as my constant in front of x, and I have a function, maybe a function other than just plain old x inside that square term there. Okay, so you're going to want to not use these and use these. Make sure you have them in your notes. Once you have these copied down, it's just a matter of recognizing which is which. So here's the first example we're going to tackle. And knowing now that these come from only one of these three types of functions, you should be able to pick. In this one, you should be looking at the arcsecant because of this x in front. Okay. This one has a negative, so I'm just going to factor that out to start. And then I have dx. So this follows the formula quite nicely, right? Because if I'm following this form, I have u is x, a is 2, right? So I'm just going to note that u is x, a is 2. And then I just follow the model, so equals 1 over 2, and I'm going to make sure I don't forget my negative, I'm going to bring that down. So 1 over a, arcsecant of x over a plus c, and this gets an absolute value. Okay, so once you have noted which type of function this falls into, this is actually not that hard. Okay? The rules look a little scary, but they follow the rules closely. Here's another example. So I'm going to go back up to my rules here. And this is an arcsine one. I'm actually just going to bring this down so we can look at it. Because here we're going to have something a little more interesting happening. So 1 over a squared minus u squared du. Okay, well, let's start by factoring out this -7, actually. So we'll get 1 over all this still. Now, we have a squared, so I'm going to let a equal 6, because 6 squared is 36. U squared, well, u squared is 36x squared, so u has to be 6x. That means now, notice it's du. du is 6 dx. So there's some u substitution coming into play here. So I have to make that substitution as well. So let's do that first. So I'm going to say -7 times the integral And we have 1/6 du we're plugging in. So I'm just going to write the 1/6 in front. And then I'll leave the 1, and I'll replace du with dx, or dx with du. And then I guess we can say 36 minus u squared. And then we'll integrate. So the rule here is arc sine u over a. So I can factor all this out. So -7 over 6 arc sine u now is 6x, and then a is 6, and then I can simplify 6x over 6, obviously. Okay. So the u substitution rules still apply. Notice this is du in these integrals, not dx. So anytime your u is anything other than x, you have to do a little bit more work on these. Make sure you follow my steps here before we move on. So my last one's going to be a tangent. And I know that by looking at my rule. Arctangent is the only one without a square root in it. I'll bring this down so we can look at it. Oops. Okay, so here's my derivatives rule. So again, I have a u and an a. My a is going to be 5. 5 squared gives me 25. U, again, same as the last one, is going to be 6x. 6x squared gives me 36x. So du is going to be 6 dx. And then 1/6 du, same as the last one, is going to be dx. Okay. So I can make that substitution right away. So this is going to give me the integral 1/6, still 1 du, u squared, and 25. Okay. And then my a is 5, right? I'm going to now just follow the model. So 1/6 is still chilling, and then I have 1 over a, and a is 5, right? Arctangent of u over a. So u was 6x, a was 5. Oops, I keep writing a instead of 5. Plus c. So that's my integral, and then I want to simplify it some. So 1/6, 1/5 becomes 1 over 30. Arctangent of 6/5 x plus c. Okay. So this takes a little bit of practice, I think, to make these substitutions. Again, good practice for Calc 2. Not crucial this year, but good practice for Calc 2, and these are good integrals rules to start to kind of cut your teeth on. The two things to watch out for, well, the one big thing to watch out for is that du. So make sure anytime your u is anything other than a plain old x, you're substituting in du for dx.